17A. You need to get your head around the terminologies we use in chapter 17. So we're now moving away from discrete data, continuous data, because sampling can actually work between either. Sampling is now about how do you predict for a chances of a population, which that's what we're going to talk about, population versus sample. And how do you do it realistically and scientifically? This is what we're sort of teaching you. Now, for those who do SPECS, you would have seen this already, so you should be all right. Population is a set of all, write this in, members, eligible members of a group which we intend to study. So if you do science as well, psych, we often talk about population and samples as well. A sample, so let's fill it in, a sample of the population, and we extract the findings to the population. Sample must be representative. All right, so a sample is like in a big group. Think of a population as a big circle. That's your population. Sample is I take a group out of that population. So, it's a sample, subset. A sample is a subset of the population. And we use that information to predict something about the population. But one of the things that you need to make sure is a sample has to be representative. Okay, so meaning it has to be a subset. If I'm saying that I'm looking at people who enjoy gaming, yet then I go look at people who don't like gaming. You know, like I pick a group of people, I'm like, do you like gaming? Like, no, okay, cool. Tell me if you like gaming. Whatever they say is irrelevant to the study that I'm interested in, right? So P is the big intended target audience. That's population. Sample is the group of people that are part of the target audience. Okay. Now, we use A. Now, those who do psych will know these words. Simple, random sample to give every member of the population an equal chance of being selected. What does this mean? When you pick a sample, just think about it logically. If I was interested in knowing whether students between the ages of 15 and 18 like playing games, right? Then it would be wrong of me if I only then targeted students who were, say, 15 or 14, right? Because then that group of younger students who may not have the same responsibilities as an 18-year-old or 17-year-old who's doing VCE has more responsibilities and they're more mature. So then by targeting it, I'm not giving every member of the population equal chance of being selected to study. So that's why we call it a random, simple random sample, meaning we're going to do it some way that everyone has an equal chance of getting selected for the study. And that usually is like a hat draw or something like that. And you guys can represent that on a CAS calculator. And that's what part 17A is going to teach you. Okay. Next one. What's another term you need to know? Population parameter. Sounds like a scary name, but all it means is when you have a population, let's say this example, you have a population of 1,000 students, 600 of which are female, then the proportion of female in that particular population is 600 over 1,000, because there's 1,000 people, the target audience I'm looking at, and 600 of them has identified as female. So the population proportion is a population parameter. This bit, that's called a population parameter. Okay? In a way, you kind of think of it like the chance, but we call it a parameter because that's the proportion that we're interested in for our target audience. What's the key thing to know? Population parameter is constant. What does that mean? That means in this group here, the target audience is 1,000, 600 for female, then that doesn't change. No matter how many little samples I take out of it, the point is the population parameter or the proportion overall is 600 out of 1,000. Okay? An example of that is, say, our classroom. Let's do a quick idea of population. Let's say my target audience is people who have an Apple phone. Can I get a show of hands who have an Apple phone in this classroom? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have Apple phone. 11 people out of, there's 22 students in this classroom usually. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. So today there's 18. So the population parameter for this classroom who have an Apple phone is 11 out of 18. Okay? But, so I'm going to write on the side, population, thank you. If I picked out a sample, thanks group, eyes and ears towards the board, difference between parameter y1 is constant and 1 is not. So the other is called a sample statistic. And what does the sample statistic mean? It just means in this class, what if I picked 3 students at random? 3 students I'm going to pick randomly. So n equals 3, right? So the people I choose is only a group of 3. But I have to give you all an equal chance of being selected. Can I go to the show of hands who had Apple again? Okay, this would be unfair if I went and did this. Here's my group of 3. 1, 2, 3. Then I go over here, I'll go 1, 2, 3. And I go, all right, let's have a look at the proportion. That group there was 3 out of 3, Apple phones. And then I go over here, 3 out of 3, Apple phones. Then I say, oh, there's a 100% chance of students who have Apple phones. That's the chance of students at any school, at Viewbank College or anywhere, has 100%. The problem there is, yes, I had a population proportion. I had a population group, target audience. But the way I'm choosing my sample was a problem. I'm targeting. Like, I'm not actually giving you guys an all equal chance of being selected. You get me? That's why it needs to be a random sample to be representative. So you guys need to represent 15-year-olds, students at a school who has a phone, right? Now, notice here, if I did give you all an equal chance, let's say I picked a name generator and it randomly generated names, okay? And all of you had an equal chance of getting selected, and 3 students come up, and I could have Lydia. Do you have an Apple phone? No? It's okay. Here we go. We have no Apple phone, so I'll do it Apple dash for no Apple phone. Ella, do you have an Apple phone? Oh, you do? Okay. We've got an Apple phone, and Noah, do you have an Apple phone? Oh, you do? Okay. So, notice in this group, how many Apple phones there are? It is now 2 out of my 3. But if I chose another 3, if I did another random one, it's very likely that that probability is going to change, or the proportion is going to change. So this is what we call a sample statistic, because it changes depending on which group I choose. The more groups I choose, each one has a different sample statistic. Each one has a different sample statistic. But overall, we know that there are 11 students out of 18 who have an Apple phone. That's constant. So this is called the population parameter. It stays the same, but each sample statistic, we do a p hat, it's different. Each p hat, every group of 3 I choose is going to be different. Some of it will be 3 out of 3, some of it will be 0 out of 3, some of it will be 1 out of 3. That's the study that we're doing in chapter 17. We're studying the sample size, because realistically, I cannot grab a target audience. If I said 15-year-olds with an Apple phone, I'd have to go and get every 15-year-old in the state, in the country, and there's no way I'm going to be able to do this. It's not feasible. So then we say, well, what's feasible? Logically, when people do studies, you grab representative groups, and that's what we do at university when you do research. You have to then take a small group, 30 to 100, how many volunteers you can get. But then from those volunteers, how do we predict? Does it represent the population? That's what we try to do. And that's the study of chapter 17. How do you use a small group to predict for something that we don't know? Okay? All right, so what are some keywords you've learned so far? Population, sample, population parameter, meaning it's got to be constant, the proportion is constant, and sample statistic, this one varies from group to group. Okay, so each group of 3 that I choose will have to be different. So however, the larger the number of samples grow, so instead of 3 students, if I pick 20 students, the larger the numbers, the more the average becomes or gets closer to the actual population parameter. The problem in reality, if you think about it logically, it's very hard to get a large sample size. Meaning if you did a research, how do you even get 1,000 people to volunteer? And if you wanted to, especially like uni back, So back then, what Sarita just did, the money idea. And it was really hard. So for me, what did I have to do? We had to do things like we collaborate with the student union, and they have the food court area. So we get like these coupons, and we have just a caveat on the bottom. It's like, if you join to do this study with us, you will get a free coupon for a free coffee. Something like that. And if they like it, they can come. But the problem is, where do we get the funding to have free coffee for students? So it gets limited, and money is always a problem when you're doing studies. So the larger you want it, it's harder to do. But the larger it is, the more accurate it can be. That's the idea. So the study today is saying, well, what do you do when you have little resources, meaning you don't have money, but you only got a few people in your sample, versus if you were able to make a large sample, versus if you have small population or big population, how does it change your calculations? Is what chapter 17 is. Yeah? All right, let's do an example. Let's do an example, team. Here we go. Let's look at this. I want you to read this line. This is a typical psych type of question. Those who do psych, you would be able to identify this now. In a certain school, 35% of the students travel on the school bus. A group of 100 students were selected in a random sample, and 42 of them travel on the school bus in this example. What is the population? That's a typical psych question for a year 11 SAC that I would have wrote back then. What is the population in this case? Because it's testing your understanding between population and sample. What is the population? All right. Remember, population is the target audience. For those who thought of a number, you're wrong. We're not talking about numbers here. It's the target audience. What is our target audience? It's the students at a certain school. So we don't know who those total number of students are, okay? What's the 35% though? Be careful with it. What's the 35% of students travel on a school bus? What are they trying to say? What is this telling us? What's the 35%? So think about it. In a certain school, so say Viewbank College, 35% of you travel to school on a school bus. What am I saying? What am I telling you right now?
That's what, the chances of a student going on a school bus.
Chances of students going on a school bus, which is 35 out of 100. But remember, chances, in this study here, we're talking about proportion. Now, which proportion is this? Is this the population parameter, or is this the sample statistic? Which one is this? What's the 35%? Parameter. Because this, I already told you, it's like, I don't know how many students there are in the school, but I can tell you 35%. That's the guaranteed. It's constant. Doesn't change. This is the constant. The 35% is constant. So this represents, when they say, what is the value of the population proportion? It is 35 out of 100. That's your population proportion. Because it's your target audience. How many of those target audience? What's the proportion of students that take the bus? 35 out of 100. That's the proportion. Then what is the sample proportion, which is the sample statistic? What's the sample statistic? Sample statistic. All right, you guys are slow on this one here. This is an N group of 100. N equals 100. They were selected in a random sample and 42 of them travel on bus. So this one, out of this 100 that I chose, 42 out of those 100 that I chose is my sample statistic. Can you see that? Because the 100 I chose could be different every time I choose 100. Just like before, every group of 3 students I choose will have a different proportion. So the 100 doesn't mean that it's always going to be 42 over 100. It can change. And if it changes and varies, it's your sample proportion. Can I get a show of hands who have a better understanding now? Because that's 17A. That's literally what 17A is trying to teach you. Okay, we've got 1, 2, 3, 4, 5, 6. Okay, good. That's 17A. 17A is learning sample proportion, proportions, sample, population, the proportion, so statistics versus parameter. That's the idea. Then there's a CAS work. So here we go. Flip over the page. Here we go. Let's take this example. So remember, we have to do simple random sample. Everyone has to have an equal chance of getting chosen, right? So how do you do it on a CAS? Using CAS, if you have to select a group of 5 people, Group of 5 people. Group of 5. And everyone has to have an equal chance. How do we do it? Grab at your CAS. Here we go. This is how we do it.
Oh, yes.
All right, let's begin. Year 12s, thank you. Can we grab out our CAS? Thank you. I'm going to teach you how to do a random sample on your CAS. I've given you enough instructions for you to do it yourself as well, but let's just guide you through it. We first do something like this. We give every name or every member a number. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sorry? Yeah, whatever came to my head during that time. I was thinking of the Ninja Turtles, Raphael, Donatello. And then at some point I thought about, I don't know, Prince, I have no idea, whatever came to my head. Yes, the Bibi. I don't know why it's popular, but I do know what it is. All right, so we've assigned, you don't have to assign in the order I did, you can assign whatever order you want. I'm just giving everyone a number. Shh. Quiet down, thank you. All right, on your CAS, you need to type in random seed. So ran seed or go menu. I think it was probability, random. So menu 5-4. Random seed. What is random seed? It means that your calculator and my calculator has to start somewhere randomly different. Okay, you pick any 4-digit number. All right, whatever 4-digit number you like. So I could do 3, 3, 5, 4, 9. I don't know. You make up your own. Okay. Yeah, probably could. But the point is, it needs a reference. Okay, your calculator uses a reference, so that's by reference. You make up your own reference. Doesn't matter. Then now we actually generate it. They just need a basis for generating random numbers, right? So we ran seed. Now to give every person an equal chance of being selected, we're going to then select either integer numbers or decimal numbers. Now, if you want decimal numbers, so probability, random, when you go random number, that will have decimals. When you go random integer, that will not have decimals. Now, in our case, we gave everyone a whole number, so it has to be integer. So random int. Okay, so random int over here. So if you did ran 5, generates 5 random decimal numbers. But if you ran int, then you got to tell it where does it range from. So in our case, we ranged from 1 to 16. So I'm going to go to 1 to 16 now. And how many people am I selecting? I'm selecting a group of 5. Okay, so it'll be 1, 16, and then 5. So that 10 is the number of people I'm choosing. So I'm going to change it to 5 now. And it gives me 5 random numbers. 116 is the number, the smallest number you have and the largest number you have in integers. So each, I did too. It's random. So we just have to do it again to get another person to add on. So it looks like I got, who do I have? 15 is Manson. I've got Manson. I've got 7, which is Minsu. I've got 12, Violet. And 8, Brock. And my last person's Violet again, so I'm just probably doing another random int. Well, I can do random 1. And I get 3. So, who's that next person? Joey. Because if you pick it, you can be biased. And when we pick, we might just pick the first 3, or we go in a diagonal. So then that means these people are less likely to be chosen. So if you go like that, go like that. So that's why we don't do that. To give everyone an equal chance. It's like when I select students to answer a question. Have you noticed usually people sitting in the back gets less likely to get selected? Usually the people at the front. So even though I'm choosing, I have to make a conscious effort, and then it becomes biased. It's never random. You know what I mean? So this is 17A. 17A is practicing to get that. So far, so good. I'm going to pause the video.